Hello, I am Developer Relations Engineer David Jones-Gilardi. And today I want to bring you through the basic kind of 101 of RAG. RAG means Retrieval-Augmented Generation. And so what we're going to do is we're going to break down kind of what RAG is, how you use it. I'm going to show you some examples. And then we're also going to look at vector embeddings because to really understand RAG and how it works, you need to know a little bit about vector embeddings as well. Okay, so let's go ahead and very quickly just talk about the problem space. So imagine for a moment that you are in, say, ChatGPT, right? And you ask a question like an open-ended question, like, when did I start coding? Now, what do you think is going to happen? Well, chances are it's not going to know what you're talking about. It doesn't have context, right? Why don't we go ahead and do this live? Come over here to ChatGPT. I'm going to say, when did I start coding? Okay, and let's see what it says. I don't have any specific information about when you started coding. If you'd like me to remember that detail, feel free to share. Right? So it just doesn't know anything about my domain, my personal domain. And this is generally like this for any of the large language models or LLMs that are out there. They're trained on this huge corpus of knowledge from the internet and such. But unless you're a celebrity or you have some particular information that has been put out in the public sphere, there's a good chance they don't know about you, right? It's the same thing for businesses. While the LLMs may have a good idea of like the front page of my business and maybe what that looks like, the internals are probably not exposed to them as well, right? So they're not going to have, pretty narrow kind of specific information about your business domain. So our goal here today is to learn how we can augment the knowledge of the LLM in real time to then give it this kind of information. So that's what we're up to right now. Okay, so let's come back over here. And what we need to do first to really understand RAG, and by the way, I'm going to mention that acronym a couple times. We're going to get to it. We will dig into what RAG actually is. But in order to really understand what RAG is, you need to know something about vector embeddings because that pretty much forms the basis, the foundation of everything we're just about to do. Okay, so what are embeddings? Embeddings are a representation of data that computers can easily understand. Let's do a little exercise. What I'd like you to do is mentally group these. I'll give you a moment, however you want to. Okay, great. So chances are, even though you and I probably had different properties in mind when we grouped these, that you could probably, or you may have grouped these similar to what I did here. Let's take a look at the coffee and tea. Coffee, tea, they're both drinks, maybe served in mugs, sometimes hot and cold, right? They're more similar than, say, animals are. Right now, I've got three animals down there at the bottom. I have the cow, the pig, and the tiger, yet two of them are usually associated with being domesticated, maybe on a farm, where the tiger, not so much, right? We usually don't see those in a farm, maybe a zoo or out in the wild. Yet they're all animals, but there's some differences. And then finally, up in that top corner, you see the computer terminal there with my generative AI version of Zork. Zork never really had pictures that I remember, but anyway, which is completely unlike these other things. And yet, intuitively, we were able to immediately start mapping these types of properties together, right? So the real question is how do we get that kind of information? How do we map these in a way a computer can understand so we can use it? Okay, so let's take that same example we had a moment ago. Now what I'm going to do is we're going to put this here on this 2D coordinate grid, right? And then we're going to add some properties. So kind of like, let's break down what's going on here for a moment. Notice my y-axis, the vertical axis, you see wild versus domestic. And then on the bottom horizontal axis, the x-axis, we see non-living versus living. Now to be clear, these are just some arbitrary properties that I decided to use in this example, right? It could be all sorts of things. But now you can see where we can start to assign some values, some numerical values to these properties in this very simple two-dimensional space. Let's take the coffee and tea example yet again. Now you might be looking at that and wondering, well, wait a minute, your x-axis there says non-living versus living. Coffee and tea aren't living. Why aren't they over, all the way to the very left, like in the computer terminal? Well, if you think about it, they're derived from living things. So now this is kind of an example where you can start to, say, encode some nuance into the numerical values depending on what the properties mean. And it's the same thing with the tiger and the farm animals, right? They're all animals, but there is a separation between, say, wild and domestic. So now you can start to just get an idea of how we might be able to, say, extract information about certain properties of things. And now we can encode them into these numeric values that we can use. So let's go ahead and look at an example of this scenario in a vector database. Okay, let's pop over to our database here. Here we go. Okay, great. So now what you're seeing is DataStax Astra Vector DB, right? So a vector store or a vector database is a specialized type of database that has been optimized to both store and retrieve vectors, right? Now, if you're looking at some of the values here, if you remember the values that we had here in our 2D plot, you can see like the tiger is 0 0.7, 0 0.3. Again, we assign these numerical values based on the properties that we assigned. You can see I have the same values here. So tiger's up on the top. You can see that it's the same exact values. Now, you might look at this and wonder, what's going on here? Why is this special? These are just arrays. But in a vector store or a vector database, something special is actually going on. So it's not that just we're storing arrays of numbers, but these are actually being represented as vectors in the system. And what we're going to do is we're going to use those vectors to calculate the angle distance, right? So you might have heard of something like cosine similarity vector or something, or cosine similarity search. So I'm going to, when I press search here, what it's going to do is the vector store is now going to do a vector comparison. It's going to say, take this vector, 0 0.7 and 0 0.3, and I want to compare that to the other vectors I have in my system. Now notice here, you'll see this similarity score on the left-hand side, and the range that we're working with is 0 to 1. So 1 means exact match, 0 is not similar at all, right? So what you can notice here is that the vector store, when I perform a vector search, compares the vectors, you can see I get this range of values here, where the tiger obviously is an exact match, but then we have this relationship to pig and cow, right? You can see by their similarity scores, very high similarity scores, but then tea and coffee and then computer terminal are very unrelated. And what's super cool about this, I can go back the other way, right? It doesn't, whatever direction I go, you can see that these relationships are maintained, right? Because again, we're doing a special kind of calculation in our vector store. Now, this is like a super simple example, just only 2 dimensions. Let's go ahead and take a look at something a little bit more involved. Now, this is an example of what a real embedding looks like, generated from a text embedding model I got from OpenAI, text embedding ADA02 on the phrase computer terminal. This is 1,536 dimensions worth of information. If you take a look at the example down here, the asterisk here, you'll see that it's encoding semantic and contextual information about computer terminal, and even some things potentially like concepts like things like commands, programming, displays, so on and so forth. So it's a way that we can take information and we can encode it in these arrays, and then we can use these distance calculations to see how alike one thing is to another. So let's go ahead and take that example to the next level. Okay, great. So what I'm doing here is I actually have a whole set of data. It includes all the ones that we were just talking about, but then it actually has all sorts of other things in here, right? And it's just a set of data that I built specifically for this need. But one thing that is happening here is you'll see this dollar vectorize here, and we are in all these cases there's a description. So what I've done is I have taken the description in every one of these cases, and I have vectorized that information, or I have put it through text embedding model to generate these huge arrays, right? As a matter of fact, if we take an example of one of these arrays, just to kind of show this off real quick, I mean, they're huge. They're absolutely huge, right? It's, again, these are these huge arrays that are representing the information that we have there in our description. Now, to be clear, in Astra, we have a feature called vectorize, right? What that allows you to do is it allows you to, on ingest and at query time, automatically vectorize your data. Because like right now, if you say you had a set of data and you wanted to generate vector embeddings with most vector stores, you would actually have to go to a provider like OpenAI or NVIDIA or Mistral or something like that, Anthropic, and you would have to generate the vector embeddings that you wanted and then put them in your store. In Astra, if I go to integrations over here, you can see I have all these different providers, and all I have to do is go to, say, OpenAI or Mistral and go get an API key. I can provide it here. In the case of NVIDIA, it is pre-installed and it's free. It's just part of the system. So I'm going to go ahead and use NVIDIA in this case. And that's the example you see here. So I'm using Right now I'm using vectorize. So what that means is when I put in a search query and I search, it'll automatically vectorize that text, put it into the same vector space as the item that we've stored in our vector store and do this vector distance calculation. So let's go ahead and grab some examples. How about a device used to play video games? We'll say device used to play video games. And then we'll say, give me the top K10. Boom. Now check out what happened here. So I literally just did a natural query, like a natural language query. Device used to play video games. It's not a wildcard search. It's not a keyword search or anything like that. And then look what happens. You'll notice that I get these items. Now this, even though it's super, you'll see these very close, kind of get a very high similarity score, but look what happens. So I get my game console in the first one, but then I get all these other related items. Now, this data, this is being compared by vectors, right? And all of these again are the descriptions being vectorized. So here with this type of vector similarity search, I'm able to tease out relationships that might be really hard to do with kind of traditional searches. So that is kind of what you're getting, at least with the text embedding model, right? That's kind of what's happening under the hood to enable all this. Okay, great. Let's go ahead and move on. And by the way, that was just like a basic primer on vector embeddings. If you want to know more, scan that QR code right now. That'll bring you to a blog post that gets into a lot more depth and detail, and will kind of level up your game on vector embeddings. All right, great. So now we've learned something about vector embeddings. So what is RAG, right? So the acronym stands for Retrieval-Augmented Generation. So what does that actually mean? Let's break down the acronym. So retrieval, what we're going to do is we're going to retrieve data from a vector store in this case. Then we're going to augment the knowledge of our LLM. And then by augmenting the knowledge by setting its context, and we're going to demonstrate that here in a moment, then you are changing the generation. You're augmenting the generation. Because if you remember our example before, when I asked ChatGPT, when did I start coding? It didn't know anything about me. So our goal here is to give ChatGPT or whatever LLM, right, the information it needs in its context in real time so it can give me a better answer. Okay. All right, so with that, let's go ahead and get coding. All right, let's bring up the scenario. So let's break this down. Let's see what we have on the screen here. Now on the left-hand side, I have a tool called Langflow. This is both in a version that is free and open source. If you go to langflow.org, you can go to the GitHub repo and get that. Or the version that I'm using here is DataStax Langflow. So as part of DataStax's AI paths, we have both Astra, VectorDB, and Langflow. And the cool thing, these are totally free to try out, right? You can, our free tier is free forever, so you can get in here and try them out. But the general concepts, even if you don't do that, still apply, right? So we've got Langflow here on the left-hand side, and Langflow allows you to visually build out Gen AI workflows, right? So you can, instead of having to, say, learn a bunch of code that you have to go in and kind of maintain and everything, it allows you to just drag and drop components in. It is completely model agnostic, has support for all sorts of models, even including a llama, which allows access to local models, all sorts of different vector stores and everything like that, right? So we can use this to very easily and quickly build out a RAG pipeline. Now, on the right-hand side, all we're looking at here is just a PDF. This is a PDF that I happen to have in my career. But why I'm bringing that in, why I want to point that out to you is this part right here. I want you to notice it says the beginning, I'm around 8 years old, and I started learning how to code games on our Commodore 64. Because what I want to do is I want to get the information from this PDF into my vector store, so then I can perform a vector similarity search that I can use to augment the context of the LLM. Okay, let's go ahead and do that. I'm going to go ahead and separate that out, and now we can zoom in a little bit. Now, a couple things about Langflow here. I'm actually just going to back out real quick. And, Langflow, if I didn't have anything else, I have a bunch of projects, obviously. I do lots of things in Langflow. But if I didn't have anything else, I would have this new project over here. And if I click on new project, you can see there's all sorts of templates, right? So if I want to build a RAG pipeline, I would start with vector store RAG. The flow that we're in right now that I'm going to bring you through is just a slight modification of this one for my particular data set. But this is what you would do. You'd start with vector store RAG, and you would get something that looks, honestly, just like this. Now you notice that in Langflow here, at least on our RAG pipeline, there are actually two sections, right? You'll see down here, we have the what I call a generative section. This is the part where we're going to generate our data and store it in our vector store. And then up here is the query portion, right? This is the part where we're going to now query against our vector store and augment the LLM. So let's go ahead and break these down. So first thing first, come over here and we'll look at the generative part. Now, in Langflow, I mentioned that there's a bunch of inputs and outputs and everything. If you take a look at the left-hand side, you'll see these components here. You'll see I have inputs, I have outputs, I have prompts, so I can, prompt engineer and such and do that right there, right here in the flow. I have all sorts of input mechanisms, things like that, that allow me to load files or HTML or whatever, right? In this particular case, this everything in 20 slides PDF is that one that you saw a moment ago. So I've loaded that in here, and then I'm going to iterate through its data. I'm going to then, as I iterate through, I'm going to generate those embeddings and I'm going to store them in my database. Okay, so let's go ahead and break down each of the components. While we're talking, I'm going to go ahead and run this real quick. Now, one thing I'd like to point out is I am using Astra Vector DB in this particular case. I've set a collection name to Langflow. The component will automatically create that collection if it does not exist, right? So on the first run through, it's going to run, it'll create that, and then it's going to set its data. Now let's look at each piece here. So I mentioned that I was loading that file. So you can see here, I've got the PDF. You can see all of the text from the PDF is in here. Um, and that is, it's essentially what this component does. Now Langflow allows you, this is super cool. I can just wire these up, right? So I'm wiring up from the output of my file into the input of my split text. Now, what is this split text thing? What am I doing here? So when you are creating a RAG pipeline or something like that, or even when you're sending data into an LLM, if you think about it, if you had like a whole book or books, right? It wouldn't do you much good to just take the whole book in its entirety and just throw that into the database in one huge chunk. Because there's a lot of information in there, and you might only be looking for a specific piece of that information. And that's exactly what we're doing in a RAG pipeline. So there is a process called chunking. We're gonna run through, we're gonna iterate through our PDF in this case, and we're gonna take chunks, and then we're gonna vectorize those chunks, and that's what we're gonna store in the database. So if we take a look at the chunks here, you see in this case, I'm using this split text component. This is part of the basic template. But if you were to come over here and say like split or whatever, you see there's all sorts of other ones that you can use. Now, what I'm saying here is that I want to chunk through every 1,000 characters. I have an overlap of 200, so I'll have some crossover between my chunks. And then I could choose a separator if I wanted it. Now, in this case, look what happens. You see, I get these chunks, right? I have 3 of them in this particular case. It's a very small example, but it works, right? I get these chunks of text, and this is a very simple chunking mechanism. But then what we're going to do next is we're going to take that data. We're going to apply each one of those chunks to our embedding model. Now, again, Langflow is embedding model or model agnostic, right? So OpenAI may be the one we use for the default, but it's not the only option at all, right? There are all sorts of options here that you can use. And in this particular case, I'm going to use the text embedding ADA02, right? You may have recognized that from the computer terminal example we used earlier, right? And then there are other, depending on which embedding model you pick, if I chose a different one or something, you'll see that they have different options and such that you can choose from. So again, now I'm just going to stick with this one in ADA02. So it's going to take each one of those chunks. It's going to go ahead, convert them into vector embeddings using the model provider here. Notice this OpenAI API key. So Langflow does have this concept of globals. So you see I have a set of global variables. If I were to say I want to add a new one, I could, put something here. And then I could say, hey, are you credentialed, right? Are you a key that I want stored securely or something? Or are you just a generic string or something? You put a value and it'll save it as a global. And what this allows is, it's nice because once I've done this, now that applies to all of my components throughout all of my flows, right? Hence being a global variable. And then finally, once I've chunked through the data, I'm converting into the vector embeddings. I'm then going to store that in my vector store. And I already ran this while we were talking. So if we take a look at our store, I come over here and do a quick little refresh. And let's look at our Langflow collection. Okay, great. Now, check it out. You can see I have 3 chunks and I have vector embeddings for each, right? So now I have properly chunked my data from my PDF into these vector embeddings. Now, that was the generation part. Now, one thing I would like to point out, this is the way I've got this set up here is very batch-like. You could absolutely do this real time. You're not limited to just doing it kind of like a one-time shot. Okay, so now I want to query I essentially want to query my data store and do what is called a vector similarity search to pull out the most relevant chunk that I can apply to my LLM. Because again, remember, when I talked to ChatGPT, I said, when did I start coding? It doesn't really have that context, right? So we're going to use the query portion here to pull that context out. So let's break this down a little bit. By the way, if you go to ChatGPT and you think about what we've got going on, if you think about it, we have a chat input. There's a way that I can ask a question like, when did I start coding? Underneath the hood, whether you know it or not, there is in fact a prompt. There are a set of instructions that are telling it how it's going to respond to you and such. Then you're giving it some information maybe, and then it gives you an output. So if we take a look at what we're doing here, it's actually much the same. I have a chat input, right? I have a chat input that I can just literally drag and drop out here, or a text input or something like that. And then if I kind of ignore a couple things for a moment and go to my prompt, so I have a set of instructions, right? So in Langflow, by the way, when you have a prompt, anything that is encapsulated in curly braces will become an input. So notice that both context and question are encapsulated in those curly braces. And if I look at my component, you can see context and question are inputs. As a matter of fact, just to kind of demonstrate that a little bit, if I said something, and then I came in here like this, now all of a sudden I have something as an input, and I can just wire them up, right? So it makes super simple, makes it a super simple, kind of process to set these up. Okay, great. So now I have a very simple prompt. I'm telling it in this case, using the context above, and here's my context variable, answer the question. Now, in this case, I'm telling it be quick and concise, use one sentence maximum, things like that. The LLMs tend to be chatty. Sometimes you have to be very specific in the instructions you give them. This is an example of that. Let's go ahead, by the way, while I'm talking, I'm going to go ahead and run through this. Now, once we have our prompt generated, that's going to feed it to the LLM. Now, in this case, I'm using OpenAI's GPT-4o Mini. I could choose from all sorts of different models. Again, I have all sorts of models here that I could choose. And if I wanted to choose something else, let's say like Grok or whatever, I could just come over here, give it an API key, wire it up, right, do the thing, and now I can use a different model. It makes it super simple to do that. And then finally, once the LLM has had a chance to actually chunk on whatever it is, or answer whatever it is, it'll give it to this output. And what's super cool is there's this playground here. So I can get in and I can experiment. I can actually test out my flow and see how it's working for me. And notice that when I ask the question, when did I start coding? Now it gives me the correct answer. You started coding games on the Commodore 64 around the age of 8. So now we were able to augment the context of our LLM in real time so it could provide an accurate answer. So how did we do that? Okay, I said I skipped over some components before. Let's go ahead and take a look at those. Again, we start with our chat input. We're going to say, when did I start coding? But now notice what's going on here in this little section. I've wired up the output of our chat input to the search input of our vector database, right? I've provided some information, things like the collection. Again, it was called Langflow, a token so I can authenticate. And then it's going to do a vector search against when did I start coding. But in this case, how does it take the string when did I start coding and then convert that into the same embedding space, the same vector space as the other data I had already stored as part of my RAG pipeline? And that's where this particular component comes in. Now notice these match, right? Notice that the embedding model, the text embedding 80A02, text embedding 80A02, those match. That's on purpose. Matter of fact, that I would argue you need to do that. The embedding model should at least be in the same family, but they should absolutely, in general, they should be the same model. Because if you think about it, if you were to use a completely different model, a text embedding model in this case, to generate those vector embeddings, and then later on you come with another model, another provider, and you try to search against that, they're not kind of comparing the same types of properties, right? So you need to make sure that whatever you're using in your generation, you're also using at query time. Okay, great. So now we do our search. Now let's check out what happened. Boom. Notice that out of the 3 chunks before, that when I asked the question, when did I start coding, it pulled out one chunk that it thought was most relevant. Notice in particular the information that is probably what we're looking for, right? That happens to be in that one chunk. And now we're going to pass it over. All we're doing, this is just a little parse component. So if you notice the results come out, they have this file path and text. All we want is the text. So I'm going to go ahead and use this parse component to pull out the text. You can see now it's just the text. Again, we're wiring that up, output to input. I want this as my context, right? remember we had this context variable before. We're saying use the context above. So I'm going to give it some context programmatically. So if we inspect this and we look at the output, look what happened. It says using the context above, and now it's got the context. And then again, it's inputting my question. When did I start coding? This is what's being fed into the LLM. So let's do something fun. I'm going to pull this out. Let's go back to ChatGPT. Let's give it this information, right? I'm going to give it that context. I'm going to do the same exact thing. I'm going to ask the same question. What's it do? Now, by the way, while we're waiting for it there, you see that little memory updated. One thing that a lot of the major providers, the LM providers and stuff has started doing, they started adding more and more capability. One of those is it updated the memory. If I now ask this question again, it's going to remember. It's almost like a little RAG pipeline itself, right? So up to you whether or not you use those types of things. But when we're talking about like for your own applications, you're probably going to want to use a vector store. But notice what happened now. Now that the LLM has the correct context, it also is able to give me the correct answer. Where before, if you remember, it didn't have that information, right? So again, this is the same, LLM that's been trained on all this huge corpus of knowledge, didn't know anything about me. I gave it the context, now it does. Now it gave me the correct and accurate answer. And that's exactly what's happening here, right? So we're just passing this into our LLM. Again, we're wiring up the output to the input, and then it gives me the output. And that's what you see here. So a question I get asked a lot is, well, given the context windows of LLMs today, and the fact that there are some major providers out there that have millions of tokens, right, that you can give in a context window, a question I get a lot is RAG still relevant? Right? Do I still need to do this? And I argue absolutely, because even if context windows were infinite, right? Let's pretend that you could just throw every single document, every single book, or whatever you wanted at an LLM. Well, one, you're paying for all of that, right? You're paying for all those tokens. It would increase the processing time on the LLM because now you're throwing all that over to the LLM and expecting it to figure that out, right? So that will take longer to get a response. But not only that, if you just if you're not sending the LLM relevant data and you're sending it all the data, right? There's a very good chance you're not going to get back accurate results. The whole point of RAG is to use the vector store, and vector, databases are, a lot more efficient at storage and retrieval, a lot faster, a lot cheaper, to then just pull out only the relevant information that you can give right to the LLM. So at the end of the day, yeah, RAG is still absolutely relevant. It is, I envision that's going to be in practice for years, regardless of the size of the context windows, and it will be cheaper for you in the long run, regardless of what vector store you use, because you're not sending all those tokens over to the LLM. And there you have it. That is how you put together a RAG pipeline with a vector store to help augment the knowledge of an LLM in real time in the cheapest and honestly most efficient way possible. Take care, everybody, and happy coding.